All right, it's Advent of Code 2021, day 3. We have some bits. Okay. Least common, just the opposite. Okay, sure. Uh, okay. If there's a tie. Not clear. Hopefully there's not a tie. Uh, it's, uh, seriously. This is incredibly annoying. Mhm. Hmm. Well, this is not going well. Oh, I really just delete my entire code? Okay, that sucks. Wow. Uh, ah, amazing. Okay, well, that was sad. Sure. Deleted all the code. Running this stupid. I don't know what this thing is. Some issue with Dropbox. Okay. So what was going on here? Okay. So we have given a bunch of binary numbers. And we want to compute the gamma rate and the epsilon rate. So the idea is for every bit position, so for the first bit, we count out that, there were 7 1 bits in the first bit. So the gamma thing takes 1 for its first bit. And the epsilon thing takes 0, because the epsilon gets the least common bit from each position. It doesn't say what to do with ties, so I guess presumably there are no ties. It should really say, but whatever. So we do that, and then we get the gamma and the epsilon bits. And then we can multiply them together to compute the answer to part 1. So let's actually code that up. Okay, so what I've done is for each line, check if it's a 1 and just record for each position basically how many votes there were for 0 and how many votes there were for 1. And then for each position, yeah, maybe let's do it this way. Okay. So we want the number of votes for 0 and votes for 1 in each position. So first, I'm going to figure out how many bits there are. Okay, and then check that they're all the same length, and then actually record this. So for each number and each position, right, enumerate gives us an index along with each character. If better to just start like that. So V is now a 2-dimensional array. E so if the gamma 0 and epsilon 1, and otherwise the opposite. And then we can just print them both. Right, so int comma 2 in Python converts a string in binary to a decimal number. That should be int. Okay, so that should be part 1. So let's see if that works, and then we can talk through part 2. Of course, I'm putting out all this random junk. Okay, so that is actually wrong. Great. X 2972336. Okay, so that is the right answer for part 1. Right, count up the votes and then compute gamma and epsilon based on the votes. And then for part 2, we need to do something else, which is basically we filter down a list until we get a single number. And so I had a bug here, which is that you filtered on the list based on the current list, not based on the original list, which I didn't understand. Okay, so we start with, right, and there's 2 lists for the oxygen generator rating and the CO2 scrubber rating. And basically we filter them. So we look at each bit in turn, and for the oxygen list, which I'm calling A, we keep all the numbers that have the most common bit at that position, right? So if there's more ones than zeros at the position we're looking at, then keep all the ones. And for the CO2 scrubber, we keep all the zeros. And now they tell us what to do if there's a tie. For oxygen, we keep the ones, and for scrubber CO2, we keep the zeros. So essentially, we can handle them separately. Okay, so what do? We start with both lists, and then for each bit, if we still have contention here, right, they say if there's only one number, we could stop, otherwise keep going. Yeah, we could define a function here, but I don't know, this is also fine. So if there's more than one number left, then count up how many are zeros in this position, count up how many are ones in this position. If there's greater than or equal to, if the ones are greater than or equal to zeros, right, this is for the A list, so the tie break says that we keep ones, otherwise keep zeros. And basically the same thing for B, except that you keep zeros, right, you just flip it. And then this doesn't actually work, because it doesn't clarify, right? It's possible that the B list could be empty if they were all ones. But I guess we're just supposed to assume that this doesn't happen, and indeed it doesn't, presumably for the inputs that we were given. So anyway, hopefully at the end you have just one number. You could also fail in a different way where you don't get down to one number. But anyway, presumably the input was constructed so that neither of those things happen, and we do get down to one number. And so we can print that out, and we can see that this produces the correct answer. So that was day 3. Yeah, really a comedy of errors on my part, but we got there in the end. That's pretty much all there is to say about that.